Welcome to a talk on how a very back-end oriented Clojure team pivoted to building a sophisticated but very front-end UI-centric set of web apps and services. I'm Rob Berger, the CTO and SVP of engineering at Omnyway, and now an accidental UI lead as well. My co-author is Isaac Praveen, more commonly known as Icy. He's done much of the work that made this project viable and is the one who really made the Clojurescript and AWS Amplify sing together. So Omnyway has been around for about 5 years now. We've developed several services with a focus on brick and mortar retailers. They all have in common the goal to allow these retailers to become more competitive to the online onslaught that they've been facing. Our most recent service was having great success by attracting international tourists to luxury retail stores. We did this by enabling US payments and promotions through WeChat and similar e-wallet ecosystems and applications. But then earlier this year, it all came to a screeching halt with the age of coronavirus. Our customers, the retailers, lost their customers and all the related foot traffic. So we had to come up with a whole new business model that would make sense in this kind of environment. The idea we consolidated around was to enable the retailers to reach out to their customers, sell to them, and fulfill orders from their stores via a live streaming commerce platform that we would build. A key goal was to make the adoption of the service as frictionless as possible. It had to be a pure web app, no app downloads, and our ability to bridge e-wallets like PayPal, WeChat, and others to retailer point of sale without any change to their point of sale would be a key to making this frictionless to the retailers. The one minor speed bump was that our team had no video experience and no front-end UI development experience. But we had to get this MVP out and start gaining customers before we ran out of money and would have to shut down ourselves. Because we had a very solid, experienced, and cohesive team, we did feel that it was possible. We have great sales, marketing, and customer support teams, and we have established relationships with some great retailers who were telling us that this kind of a service would be a great help to them. And of course, we had a very experienced and mature Clojure development team who were willing to take up the challenge. We'd all been working together before Omnyway at several different companies, and we all worked together at Runa, one of the first companies to adopt Clojure way back in 2008. So how hard could it be to doing a couple of front-end centric web video apps? We came up with a design where there would be one web app as the dashboard for the retailers, and would run primarily on laptops and tablets for administrative functions, and on phones or tablets for the video production. And then we'd have another app that would be for the shoppers and would run primarily on phones. Again, the one requirement is that they have to be web apps and not downloadable native apps, with the reason being that we wanted to not have any friction for the people to adopt this. So the dashboard has two main functions. It has the event production side, which is where we create the production upstream video. This would take the webcam of the device, usually a phone, and allow the store associate to produce the live stream. This means that, from a software point of view, we had to get all the video stuff to work, handling all the video audio source setup, formats, etc. We ended up doing this with a WebRTC client. There also is event management during the event, like things like selecting the current showcase product and chatting with the shoppers. So that all happens while they're doing the live event. And then the other major component of the dashboard app is the retail management. This is all the stuff that happens after or before the event, including things like setting up the event, and then after the event doing the order fulfillment, payment, product catalog, and inventory management. Because we actually have to keep track of the inventory during the event so that we don't sell more than what they have in the store. The shopper app is used by the shopper or consumer. This is where we really had to make the app MVP look like a quality piece of software. The UI had to not suck, as consumers are pretty used to having a rather sophisticated UI experiences. The first several iterations that we did pretty much suck. But we're now at a point where our retailers are telling us it looks pretty good. So we really went from not really knowing how to do things to really starting to get the feel for doing UI. The shopper app has to present the live stream, chat with the retailer, spew hearts when they like an item. This seems to be fundamental to live streaming events. And most importantly, it must show the products that are part of the event, including showing the current showcase item, and then allowing the shopper to buy the products either while they're viewing the live stream or afterwards. Again, we try to minimize friction and make it as easy as possible so that they can select the product, select the size and color, and then either add it to the bag to buy a little bit later and add more things, or they can immediately purchase with PayPal. Again, trying to do that in a way that's as frictionless as possible. So this is a relatively complex set of web apps, and we need a backend to support this as well. Though we had experience with a lot of e-commerce implementations, backends, machine learning, all that kind of good stuff, we had no real front-end experience, and we needed to get the first alpha release out as soon as possible, like in 2 months, so we can get some customer validation and get an MVP out within 3 or 4 months. How can we do this? So the first thing is we decided we had to choose our tools wisely. Fortunately, Icy and myself had been experimenting with Clojurescript, Reframe, and AWS Amplify. We saw that there was something there that could give us a lot of leverage with Amplify. We assumed that the Clojurescript Reframe Reagent world would make the UI stuff bearable, and we could avoid becoming JavaScript developers. Being able to stick to Clojurescript was the only way that we could take this team, which is really a Clojure team, and cope with this kind of challenge. Hopefully the folks in the audience knows about Reframe and Reagent. I'm not going to really go into too much detail there. Reagent is the Clojurescript library that makes it pretty easy to use React components for UI. It has its own state management compared to React, though. It uses kind of a reactive atoms approach. And it generally lets you think in Clojurescript and not JavaScript. And it uses a hiccup syntax to create the Reagent components and interactions. Reframe is a more app-centric state management library, but it really works well with Reagent. You generally use the Reframe for all the state management instead of using the Reagent reactive atoms. You still get the core Reagent React mechanism that when updates happen to the database, to the Reframe data behind your subscriptions, only the UI views associated with that state update as well. So the main tool we talked about is Clojure. This is a Clojure conference, so we figured that's appropriate. Clojure has been the foundation of everything we've been doing for a very long time, even before Omnyway. The big problem is that we were not familiar with Clojurescript itself or the JavaScript ecosystem, particularly for UI. We had looked at Clojurescript several times over the years for dashboards, Lambdas, and scripting, but it always seemed like the ease of use was poor and the JS library interop was pretty hard. CLJS just seemed like a dependency hell. Didn't seem like a good way to go. But then as we were exploring the current landscape, we discovered Shadow CLJS. And this was a major breakthrough once we figured out that we should be really using this over Figwheel and CLJS. The easy ability to import node libraries completely changed the game, and the kind of support the author of Shadow CLJS, Thomas Heller, gives on the Clojurians Shadow CLJS channel is incredible. Sometimes I wonder if he's an AI. I just don't know how he has so much time to answer a huge range of questions and keep putting together this pretty amazing software, which he does updates very regularly. I also put together a template repo that has all the basics to get CLJS, Shadow CLJS, Reagent, and dev cards to work if you want to use that for experimenting or just getting started. So we got the Clojurescript basic tooling and the JS library integration down, but what do we use for UI components? In our early experiments, we had played with Recom, a component library that came from the folks who brought us Reframe. But even they say in their documentation, they don't recommend it for anything but desktop apps, and it's kind of got its own thing. And we knew we had to do stuff that was pretty fancy with incorporating JavaScript libraries, and it had to be mobile first. So we had to find something else. When you just start looking around, there's a lot of different Clojurescript libraries attempting different wrappers on different libraries and different UI approaches. But either they were like really old, like from 2016 or something, or they seemed like kind of one-off experiments, or we just couldn't really tell if they're going to really have traction. It seemed that Reagent and Reframe were pretty solid, and we felt very comfortable. But we were just kind of surprised that there wasn't any clear way to, in the Clojurescript world, to do UI components, and there really wasn't that many great examples that we could find. And then also there's the whole CSS world, which seemed really kind of scary in a lot of ways. It seems like that was the key to a lot of stuff, yet that's its own whole world. So after looking at a lot of different GitHub repos and reading lots of blogs and going through some tutorials and doing several experiments, we decided to adapt React Bootstrap as our primary UI component library. The main reasons were that it had pretty comprehensive library of components. It's based on top of Bootstrap, so it has most of the CSS working, and we could kind of start out ignoring the CSS. And we figured that if we really needed non-Clojurescript people for styling and things, we could get Bootstrap people. Though it turned out we couldn't really afford any UI people within the time frame we're looking at. So we slowly learned more and more about CSS and Bootstrap, enough so that we were able to evolve the Shopper app to look good enough, and to keep improving it at a rapidly accelerating rate along with our learning curve. There still would be some things that required getting dirty with JavaScript interop. For those times when we were stumped, these two tools that I have links at the bottom here really help. They allow you to supply a JavaScript block and get some form of Clojurescript back that would work. It wouldn't usually be code you'd want to put in production, but it would show you how to make something work, and then you can refine it to make it more Clojure-y. So it ends up you don't really need Reagent component libraries. You can just take a React library, in this case React Bootstrap, and use the Reagent adopt React class to generally turn the React components into Reagent components. In most cases, it will translate the React props to proper Clojurescript maps with keywords, and you just use them in hiccup syntax as you would any other HTML element. So basically, you can stay in the Clojurescript world almost all the time. There are some times, though, when either the React components are doing kind of strange things, or you need to pass React components into other components. In those cases, you need to really get down into keeping it in JavaScript. But most of the time, you don't have to do that. So here we have an example of how we adapt the React classes into Clojurescript definitions, which we then can use as Clojurescript components in the hiccup. So the top part is these adaptions, and so we have basically a file in one of our libraries that just does this for all the React Bootstrap components, and then we can use the definitions in our code, like we show here in this myAlert function. We're just calling comp alert, which is just calling it from that library, and use it in the hiccup. And to the right hand side, we're showing how we adapted or how we customized the Bootstrap code. So in the beginning, we tried to not touch this at all, and then over time we realized we really needed to do this, both to override certain things in the Bootstrap, like even just in the carousel handle, the little arrows and things like that. And then we decided on a completely different color scheme, so that had to be overridden. So anyway, this kind of shows the technique of overriding Bootstrap by first importing the various Bootstrap files that are the kind of functions that you use in your overrides, and then the actual Bootstrap code that you're overriding, and then finally any customization that you're doing for your own components, which you can break down into modules. So that worked out in the end pretty well. Not as quite as scary, though still the styling can be interesting, particularly the layout. Yet another major learning curve was how to do video and do it in a web app. Again, we kind of assumed that this was a well understood solved problem. Just use WebRTC, and since it's a web standard. But of course, it turned out that it's one of the weirder standards and not at all standardized between browsers. Originally, we thought we could use WebRTC end-to-end, and we first prototyped with AWS Chime, which is the basis for the AWS video conferencing service. But then we found out it was very expensive for even a medium-sized live event stream that goes on for a while, and would not work at all really for very large ones. And since we didn't really need low latency, since really the live stream events is a one-way stream from retailers to shoppers, so we don't need real-time or low latency. But we still needed to use WebRTC as the origination of content, since it's the only video standard that can work in a pure web app. Everything else needs to work as a native kind of application. But we found that there's very few services out there that can ingest WebRTC and then fan it out as something scalable like HLS streams, which standard video elements can accept. We did find a server called Ant Media. They offer a server that you can run as a AWS AMI or a server, and it ingests WebRTC and fans out hundreds of HLS streams, which is good enough for our MVP. We're looking to eventually migrate to the new AWS IVS service, which is the same underlying service that they use for Twitch. So it's very scalable, and it's really designed for this kind of live streaming kind of stuff. But the main stumbling block right now is that IVS only ingests RTMPS, which is another standard, but you can't originate that from a web app. It really needs to come from a native app. So we're looking for ways around this. So we're expecting actually that IVS will probably eventually accept WebRTC as an ingestion protocol, since we know Alexa is always listening for our suggestions on how to make AWS better. I was able to wrap the Ant Media WebRTC JavaScript library with Clojurescript and make the whole video production client in Clojurescript and Reframe and React. We did have to dive pretty deeply into the JavaScript realm to get it all work, and had to get through several interesting browser-specific issues, mainly around Safari, but it eventually did work. On the video playback side for the Shopper app, this was somewhat easier. We were able to use the video.js library for playback. It's an extremely full-featured library, and it supports many protocols, including HLS, and is used by AWS IVS as their client with a special plugin. It doesn't have a React library, but it was pretty easy to adapt that to Reagent and React. So the other major superpower that we discovered was AWS Amplify and AppSync. It has been the other major thing that's really enabled us to compress the development time and get out an early alpha and beta and then the MVP. I think it wouldn't have been really possible if we had done this in a more traditional, even a Docker kind of a thing. We've been using AWS for as long as we've been using Clojure, and we've done a lot of amazing things with it. But Amplify and AppSync has really been a breakthrough in terms of being able to rapidly create integrated front-end and back-end services with as close to serverless and no ops that I've ever seen. The first thing we discovered in our early testing is that Amplify gives you a complete and sophisticated authorization system where you do almost no code and get a full suite of state-of-the-art features, including all the UI. So not just the backend, but also the UI components for doing all the things like sign up, sign in, sign out, password reset, even MFA and social sign-ons. And it's not just the backend using Cognito, but like I said, it generates the UI for you as well, with just a very simple, almost no code at all on your part. And when coupled with AppSync, this kind of authorization can be used to drive a role-based and fine-grained down to the fields of the model of the GraphQL DB. So you get, just totally amazing authentication control or authorization control. And the other nice thing is that the Amplify AppSync toolkit does all the work of configuring your backend automatically. It does all the deploying and configuring of your DynamoDB services, which are the backing stores for your GraphQL, builds the tables that match your GraphQL schema. And it also supplies the GraphQL front end to handle all the API requests and do the subscriptions, the WebSockets, all that kind of stuff. You don't do anything to make that all happen. Same thing with the API gateway if you're doing any REST type stuff. And it also handles all the hosting of your static assets. And all this is deployed in a way that will automatically scale as your load increases. Yeah, when you're starting out, you can have a really small system that's very affordable. And it would be really hard to build something that affordable out of EC2 or even containers and Fargate. So those are the services that we're using. Amplify offers even more that we hope to eventually utilize. The list is here. I'm not going to go into them, but it's just some amazing stuff. And just this week, they made a major announcement of adding an admin UI GUI where you can do all these operations that today you have to do in CLI. You can do in the UI, in the web app, and they've also made it so it's a lot easier to do that for people that are not AWS centric. But we've been using the Amplify CLI to get things set up and then move that all into our CI, which handles keeping everything synchronized and up to date based on Git pushes. So that's fully automated as well. So Amplify is mostly about setting up all the services. AppSync is really an enhanced GraphQL service that allows you to specify the fine-grained authentication, lets you wire up Lambda resolvers to handle all the mutations, and of course, it drives the configuration of the DynamoDB tables that supports the basics of the GraphQL models, queries, and subscriptions. Subscriptions turn out to be fabulous to use with the Reframe, Reagent, React world. AppSync implements subscriptions primarily through WebSockets, so you have a permanent connection between the client and the backend. It also can use MQTT for other situations, more for embedded stuff. All this, though, is transparent to your apps and to your code. You don't have to worry about any WebSocket code or anything like that. You just specify what the client is subscribed to, and I'll show you some examples of the code shortly. For us, there was, though, still a pretty significant learning curve, as all of this was new, especially the GraphQL stuff. We'd always wanted to kind of start using that, but this is the first time we've dove into GraphQL. The nice thing was that we were able to get some great, but maybe not so efficient or scalable functionality very rapidly, like almost instantly. And then as we learned and ran into issues, like things like we weren't doing filtering properly, so we were getting very large GraphQL responses back. But once we kind of figured all that stuff up, we would learn incrementally, refactor, and improve. And the environment really enabled and allowed us to do that. So I won't go into too much detail here, but one of the great things is Amplify really is nearly no ops. I just want to show that you can go from nothing to a GraphQL backend with Lambdas just using the Amplify CLI. It easily supports multiple environments, like you can spin up dev, QA, prod, or even many dev environments. And you can easily move all this kind of configuration stuff to CI for automatic deploys and updates. So this kind of shows, how you would set up the Cognito as the auth mechanism, and then some Clojurescript of how you would use that authentication services in a more customized way. Later, I'll show you how you can do this and have all the UI with almost no code. But you also have the ability to do your own UIs or have it as part of your application for lower level access to the authentication services. The second block of code demonstrates the Amplify storage feature, which is very easy to use S3 for application storage. So you can trivially use it for things like file uploads, stuff like that. And then finally, there's an example of just how easy it is to add the static hosting feature. And that enables you to have all your assets, including your code, be served out by AWS, and including all the CloudFront kind of services. And again, that's all the code you have to write to have that all built out. As mentioned earlier, Amplify Auth gives you a complete set of login capabilities, including UI, that would normally be an incredible pain for you to do on your own. So after you set up the Amplify Auth using the CLI, just getting the Cognito stuff set up, this code shows you how by just importing this higher order component with Authenticator, you can wrap your Clojure application and have Amplify handle all the sign up, sign in, sign out, and lost password. It'll actually generate all the UI for you as well as the backend. So this block of code is the normal initialization code of a Reagent app with just the addition of the with Authenticator wrapper calling your top level Reagent component. So it's that easy. Here's a quick look on how we put together all the pieces. The front ends are just a single page apps running on the browser of the clients. It's authenticated via the API gateway Cognito, and we also have a custom Lambda that does the logic of the authentication. The rest of the app's backend is all through the AppSync GraphQL service. Clients send queries and mutation requests, and some of which result in subscriptions. Subscriptions feed right in as dispatched events in the reframe in the single page apps, updating the reframe app state, which of course then triggers the UI view updates as needed. External services may trigger webhooks, sort of like the PayPal backend or the Marketo backends, and as well as updates to the S3 bucket can trigger webhooks. And the results update the GraphQL DB, and any client subscriptions to that data cause appropriate UI updates as well. So it's reactive end-to-end. AWS Amplify AppSync supports several targets, mainly for mobile. It doesn't natively support Clojure and Clojurescript, so we had to create our own libraries to allow us to use Clojurescript with the AWS Amplify and AppSync. Icy did most of this work and came up with several libraries that not just wrap Amplify and AppSync, but create meaningful abstractions around them. The primary library is Amplitude. The GraphQL client component is the one that does the most abstraction. It makes it easy to combine queries, mutations, and subscriptions in ways that make sense to a reframe Reagent application. Amplify also wraps some of the other Amplify services to make them easy to use from Clojurescript. We are expecting to open source Amplitude soon, so please stay tuned. It'll show up in Omnyway Labs GitHub account. Ambrosia is an internal library that we use for dealing mostly with the GraphQL schemas. Refund is another primary library that we're hoping to open source soon as well. And this helps us deal with a lot of the boilerplate code we found when using Reframe. It also has some features that make it a bit easier to use Amplitude's GraphQL queries with Reframe. We'll describe a few of those features in more detail in the coming slide. Another library that we came up with that's still internal is the Clojure Lambda Runtime. It's an internal library that makes it easier to use Clojure builds with Growl VM as the functions that we run on the AWS Lambdas as the AppSync GraphQL resolvers. So that's a major component for us. And then finally, Review was our attempt to create our own Reagent component library. The original goal was to come up with a library where we could plug in different React components, with React Bootstrap just being the first. We're still using it, but it was not quite as successful as we hoped in terms of coming up with the right abstractions. I think a lot of that's because we just didn't know what the right abstractions were, and we're just still learning. In many cases, it ended up being easier just to use the adapted React Bootstrap components directly. So this is an area we're still exploring, and we're looking at maybe some higher level components that are more application specific. So I wanted to show some examples of Amplitude in action. We're showing some snippets of how an e-commerce shopping cart payment might work using Amplitude and AppSync GraphQL. On the left side is a snippet of a GraphQL schema. You can see the use of connection for forming the equivalent of joins between models. And in the mutation, we show how it gets tied to a Lambda function, in this case, the payment processor. And then we have an example of a subscription that shows how the changes in the cart flows back to a shopper's bag. Next slide shows in more detail. The front-end app calls this function, which will create the cart. Amplitude gets enough info from these parameters to form the actual AppSync GraphQL query. So Amplitude actually writes the query that will be sent to AppSync. The callback of the create sets up a subscription for the client to get updated when the cart is updated. Notice that its action is to update the reframe state, which is associated with the appropriate UI views in the client app. Those UI views will update when the cart is updated because of the subscription. If you remember, the schema defined a mutation called pay. This GQL resolve function we're showing here triggers that schema model's mutation, which has the mapping to the Lambda resolver function pay. The callback of this GQL resolve updates the client's reframe state, and which then, of course, causes the update of the cart view. The second function on this page, also called pay, is what's actually run in the Lambda resolver. So this is called by the Lambda resolver, and it can be it can have arbitrary business logic, like trigger or participate in the actual payment process, and then update or mutate the appropriate model record in the GraphQL DB. Any subscription to that model would get an update and thus update its appropriate UI views. And then finally, here's an example from the refund library that helps tie GraphQL operations with reframe operations. A very repetitive pattern is that GraphQL queries or updates will want to end up updating the matching state in the reframe appdb. So this function refin eliminates that repetitive boilerplate by using the keys passed in as its first argument as keys under a result set key in the appdb. So these first two functions take the result of the GraphQL operation, and their callbacks update the reframe appdb result set cart. Views in the client will know to subscribe to that path to get the updates, as we show here in the subscription. Refin has some other arguments that allow it to be used for a range of operations, cutting down several extra lines that would have to be repeated for many GraphQL operations otherwise. So that about covers it for what we've been through. We'll be having questions and answers afterwards. Look forward to any that you might have.